Welcome to JSS 1 Mathematics Chapter 3. In this video, we will be looking at the topic factors and multiples. Alright, so in this video, we will be looking at what is a factor. We'll also be looking at prime numbers and we'll be looking at prime factors. Alright, we'll also be expressing numbers as products of prime factors. Alright, so what is a factor? Supposing I have, for instance, a number 20, okay? So what are the factors of 20? Now, what are those numbers that can go into 20 without any remainder? All right, numbers that can divide into 20 without anything remaining. So we have 1 can go into 20 times. We have 2, which can go into 20 10 times. We have 4 can go 5 times. We have 5 can go 4 times. And we have 10, okay, can go into 22 times, all right? And finally 20, all right, which can divide into 21 times. So we refer to all these numbers that can divide into 20 without anything remainder as factors of 20. All right, so a factor is any number that can go into another number without any remainder. All right, so we refer to them as factors. Okay, so let's see another example. Let's say 12. What are the factors of 12? We're referring to numbers that can divide into 12 without any remainder. So what are they? We have 1, we have 2, we have 3, we have 4, we have 6, and we have 12. Okay, so all these numbers can divide into 12 without any remainder. All right, now let's look at prime factors. But before we look at prime factors, let's discuss prime numbers. Prime numbers. What is a prime number? So we have prime number. Now, a prime number is a number that has two factors which include itself and 1. Okay, so prime numbers have two factors. All right, so they have two factors. All right, and those factors include itself and 1. All right, so example include 2. How many factors does 2 have? 2 factors. All right, it has two numbers that can go into 2, which is 2 itself and 1. All right, another example would be 3, which has a factor of 1 and also a factor of 3, which is itself. Another prime number will be 5, which has two factors, 1 and 5. All right, so we have other examples which include 7, we have 11, 13, and so on and so forth. Okay, so all these are prime numbers. They have just two factors, itself and 1. Now, 1 is not a prime number. Okay, 1 is not a prime number. Why is 1 not a prime number? Because 1 has only one factor. Okay, 1 has only one factor, which is 1 itself. Okay, so a prime number should have two factors, which is itself and 1. All right, so prime factors now. Prime factors. So remember we spoke about what a factor is. We said a number that can go into another number without any remainder. Okay, so when we talk about prime factors, we are referring to all those factors of a particular number that are what? That are prime numbers. Okay, so that is what we refer to as prime factors. So example, let's say we have 15. What are the factors of 15? Factors of 15 will be 1, we have 3, we have 5, we have and 15. Okay, so these are the factors of 15. So what are those factors of 15 that are prime? Okay, factors of 15 that are prime, we have 3, all right, and then we have 5, all right. So the prime factors will be 3 and 5. So that will be the prime factors of 15. All right. So those factors of a particular number that are prime is what we refer to as prime factors. All right. So there is what we call expressing numbers as product of prime factors. All right. So expressing numbers as product of prime factors. Now, what does that mean? It means, let's say we are asked to express a number as a product of prime factors. Let's say, for instance, we have 12. Okay. Let's express 12 as a product of prime factors. Now, it means getting those factors of 12 that are prime, okay, and then multiplying them together. All right. What are those factors that are of 12 that are prime and multiply them together to give us 12? So let's take for instance. So how do we do that? So what we'll do is we'll draw a table. Okay. So I have 12. All right. So the first thing I'll do is to find the lowest prime number that can go into 12 without any remainder. What is it? 2. Okay. So 2 can go into 12. How many times? 6 times. All right. So I'll write my 6 under 12. I will move to the next prime number, which can go into 6 without any remainder, which is what? 2. All right. The lowest prime number. So 2 can go into 6 how many times? 3 times. The next thing, I'll also look for the lowest prime number that can go into 3 without any remainder. Can 2 go into 3 without remainder? No. So I'll move to the next prime number, which is what? Which is 3. So write my 3. So 3 can go into 3 how many times? 1 time. All right. So where are the prime factors of 12 here? The prime factors of 12, mind you, everything here is a factor of 12. We have 2 is a factor of 12, 6 is a factor of 12, 3 is a factor of 12, 1 is also a factor of 12. But we are looking at the prime factors. So what are the prime factors there? We have 2, 2, 3. All right. So expressing 12 as a product of prime factors will be 2 times 2 times 3. Okay, so that is 12 as a product of prime factors. Now, let's see the second example quickly. We'll draw our table. So we have 28, all right? Lowest prime factor that can go into 28, 2. So 2 into 28 is what? 14. All right? What's the lowest prime number that can go into 14? 2 can go into 14. So 2 into 14 is how many times? 7 times. All right. What is the lowest prime number that can go into 7? Now, 2 cannot go can go, but there will be a remainder. 3 can go, but there will be a remainder. 5 can go, but there will be a remainder. 7, the next prime number, can go without any remainder. Okay. So I'll write my 7 here, and then 7 into 7 is 1. All right. So what are the prime numbers there? So remember, all these are factors of 28. 1, 7, 14, 2, and 28 are all factors of what? 28. But we are looking at the primes. Okay. So the product of prime factors of 28 will be 2 times 2 times 7. All right. So I'll leave the C part for you to solve. All right. Solve the C part and drop the answer for me in the comment section. All right. Make sure you participate. So the D part, we have 1,732. All right. So lowest prime factor that can go into this, 2. Okay. How many times will 2 go into 1,732? So 2 here, 1, 2 here, 2 into 6, 17. We'll go 8 times, remainder 1. I carry my 1. 2 into 13. We'll go 6 times, remainder 1. Carry my 1. Okay. 2 into 12, 6 times. All right. So that will be 866. Can 2 still go? Yes, 2 will go. So 2 into 866 will be 2 here, 1, 2 here, 4. All right. 2 will go into 6 3 times. 2 will go into 6 3 times. All right. So this will be 433. Now, 433 is a prime number. All right. So nothing can go except 433. So I'll write my 433. So 1,732 as a product of prime factors will be 2 times 2 times 433. All right. So that is how we express numbers as products of prime factors. All right. So in the next video, we'll be looking at writing these numbers as index form, and then we'll also be looking at LCM and HCF. All right. So see you in the next video, and thanks for watching.